In today's lesson, you're going to learn about exponential functions. So let's look at what exponential function is. An exponential function must have a x in the power. So let's see what the effect is when we substitute the x value into the formula. So we substitute -2 into the formula, 2 to the power -2. That will be equal to, using a calculator, you get 0.25. And then you do 2 to the power -1, which becomes half. That equals to 0.9. Put 0 in, you get 1, and then you get 2, 4, 8. So clearly you see it's getting doubled. So that gets doubled each time. Okay. Alright, so let's plot the points on the graph. So select this. So we'll see it's going to here. Okay, make it a bit bigger. Alright, and let's write down the numbers. And the numbers are, let's go up by 2s. So starting with 0, 1, 2, 3, -1, -2, -3. And then we've got 2, 4, 6, 8, 10. 12, 14, 16. Then we're going to plot these points. So starting with the 1, double each time, 2, and then 4, and then 2 substitute 3 to 8, and there's half, and then a quarter. Okay, so if we join these points to get a graph, so let's try to draw it. And then we keep going. Okay, so we get this graph y equals to 2 to the power x, y equal to 2 to the power of x. Okay, this is the exponential graph, and then you will see from there, you will start to see some features of the graph is that it has an asymptote. What's asymptote is, if you keep halving the value, half the 1 you get half of half is a quarter. You keep halving, but it never becomes 0, isn't it? So it gets smaller and smaller and never approaches 0. So when that happens, we have an asymptote. So there's an asymptote here. So the exponential graph gets smaller and smaller, half, 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 but there's always something remains when you keep halving. Okay, so let's do the next bit, 3 to the power x. So choose a different pen, 3 to the power -2, and that becomes 1/9, which is 0.1, 3 to the power -1, which is 0.3, get 1, and then 3, 9, next one use the calculator, 3 to the power of 2.5, equal to 15.5, that 15.6, 15.6. Alright, let's plot these points. This time I'm going to use a blue pen. So 0.1, 0 is 1, and then 1 is 3, and then 2 is 9, and then 2.5 is 15.6. We're going to join these dots together, and then the other one was 0.3, below, and then very small. Okay, so let's try to draw the graph. And then we've got this to join up. Hopefully there's enough room. Going up. hard to draw. Let me write this off. Alright, let's try again. Or maybe this time I'm going to make a bigger view. Let's look at it closer. Maybe that will work. Alright, very hard. Maybe I'll use a different pen. Okay, let's try to do this. Alright, that works well. Okay, so we've got this pen, and then we're going to continue. So that's y equal to 3 to the power x. So you can see that the 3 to the power x equals each time 1 and then 3 and then 9, and then before 1 it gets a third. But because they have a same starting point as 0, anything after 0, the 3 to the power x has a larger y value than the 2 to the power x graph. Whereas before 1, because it increases fast, it also decreases faster. So you go to 0.3 then 0.1. So this is smaller than the other exponential graph. So the green graph overtakes the blue graph after x equals to 0, and before 0, the green graph gets smaller than the blue graph. So we can observe the following. So in general, for a to the power x, the bigger the value of a, the steeper the curve. Okay, all right. And then we're going to look at the next one. What happens if you have a negative x there? And if you do that, you get 2 to the power of negative 3. You get a negative 3, which is 2 to the power 3. You get 8. And then same thing, 2 to the power negative 2, which is 2 to the power 2, you get 4. And you keep halving. So 2, 1. The next one will be half, 0.5, 0.25. Let's draw this graph using a purple pen. So dot here, dot there, dot there, dot here, and then this one, and then this one. So let's try to draw it. Alright, perfect. Okay, so we've got this graph, which is y equal to 2 to the power negative x. Okay. So let's write down some conclusions. So both of these are increases as x increases, and 3 to the power x is something, it's higher than graph, higher than the other graph, higher than the graph of for x greater than 0, and will be lower than the graph when x is less than 0. So you can see there the green graph, when x is more than 0, the green graph is above the blue graph. But for x less than 0, the green graph, which is the 3 to the power x, is less than the 3 to the power x graph. Alright, so let's fill in more information, and if we compare these two graphs, they are reflection of each other about the y-axis. Okay, so whenever you change the x to negative x, it reflects about the y-axis, and the x-axis is also called the asymptote of the curve. That's how you spell asymptote. And then the asymptote is a line that a curve approaches but never touches it. Never touches. So it's approaching 0, but it gets smaller and smaller, but never touch. Oh, sorry. Never touches. Okay, so let's save it. And we go to the new page. So that's all graph drawn for you. 3 to the power x, 2 to the power x, and 2 to the power negative x. Let's do some questions. So we're going to look at these. Okay, sketch these exponentials. The same set of axes. Okay, let's sketch this one. So this one will be 3 to the power negative 1, you get 1/3, you get 1, you get 3. And then this one is subject to negative 1, you get what, negative -1, so you get -1/3. That will be -3 to the power 0, which is -1, and then you get -3. Okay, the last one you get 3, 1, 1/3. Okay, so we're going to plot this on the graph. So clearly, this one is 1, that's 1, that's 1, 2, 3. So you have the exponential graph for 3 to the power of x, y to the 3 to the power of x. And now I'm going to use a different color pen for the other one, which goes downwards. Oops. -1, I think it's over here. Goes that way. And then you get, that's y for the 3 to the power -x. And then finally you've got the other one, which is 3 to the power, -3 to the power x. That will reflect about the x-axis, which is -1. So we can, let's write that again. These are reflection of each other again, about the y-axis, and the other one is a reflection of each other about the x-axis. Okay, so when you have a negative in front of the function, it turns the positive values into negative. Positive into negative, positive into negative. Okay. Alright, so now we're going to do another question where you have to find the point intersection with the exponential and y equal to a. So let's try to draw it. So it crosses at 1, as we know, and then crosses at 2, and then goes like this. Yx, and this is 1, 2. And then we're going to find where it crosses on the graph, y equal to 8. Okay, so that's Control Z on graph, y equal to 8. So that's 8, it's not going to scale, so you have to find out where they cross. Okay, so to find out where they cross, you make them equal. Y equal to 2 to the power x, y equal to 8. And to solve it simultaneously, you write 2 to the power x equal to 8. 2 to the power x is 8 is 2 to the power 3, so x equal to 3. So we cross that 3, and the y value will be 8. So that's the point intersection, POI equal to 3, 8. Alright, after we do this, we're going to answer the question about the domain. Domain obviously is all real x, and the range will be above the x-axis, so up. Alright, I think we've done all of it. Okay, so you can now start the exercise today. Today's exercise is 9.9J, so you do exercise 9J. Exercise 9J. Okay, good. Thanks for watching the video. We'll continue next time. So next lesson we will do unpaired functions on the graph. Again, we'll start off with table values, go to graph, and answer various questions about domain and range. What's after this? And there's cubic functions and some transformation. Yeah, so there's a lot of graphs to learn this topic. So make sure you do the homework and do the practice. That's it.